Hi everyone. Today we are starting section 5.7, integrals resulting in inverse trig functions. So what does that mean? In this section, we are learning how to evaluate integrals that turn into inverse trig functions, like sine inverse or tangent inverse. These come directly from derivative formulas you have already seen. So really, this is just about recognizing patterns. Now, let's look at the key formulas. These are patterns you want to memorize or at least recognize. If you see something like integral of du over square root of a squared minus u squared, that gives you sine inverse of u over a plus c. If there is a negative sign in front, then you get cosine inverse instead. If you see the integral of du over a squared plus u squared, that gives you tangent inverse. And with a negative sign, it becomes cotangent inverse. If you see the integral of du over u times square root of u squared minus a squared, this gives you secant inverse. With a negative sign, this gives you cosecant inverse. You don't need to memorize all of these at once, but you do need to recognize the shape of the expression. Let's work through an example step by step. We want to find the antiderivative of dx over square root of 1 minus 16x squared. At first, you might think that you can use substitution for this problem. Well, let's try. If you let u be 1 minus 16x squared, du over dx is negative 32x, du is negative 32x dx. We don't have negative 32x dx. We don't have x dx. We only have dx, so substitution will not work for this problem. Now, I want to compare my integral to the formulas up here. So let's first rewrite this. I have the integral of dx over square root of 1 squared minus 4x squared. So I rewrote 1 as 1 squared and 16x squared as 4x and then the whole thing squared. So I have a positive integral, so this side will be eliminated. I am going to compare this with the formulas on the side of the table. I need a square root in the denominator, so this one is eliminated because it does not have a square root. I want a square root of a constant squared minus an expression squared. So this one has a square root of a constant squared minus an expression squared. This one is eliminated as well because this one has a u in front. My integral does not have a u in front, so this one is also eliminated. So this integral looks like this formula. A is 1 and u is 4x. If I replace 4x with u, then I need to replace dx with something in terms of u as well. So I need to find du over dx. The derivative of 4x is 4. So du equals 4 dx. I only have 1 dx here. I don't have 4 dx. So I need to solve for 1 dx by dividing both sides by 4. So 1/4 du equals 1 dx. So I will replace 4x with u and replace dx with 1/4 du. So now the integral becomes 1/4 du over square root of 1 squared minus u squared. Let's factor 1/4 to the front of the integral. So we have 1/4 times the integral of du over square root of 1 squared minus u squared. And the integral of du over square root of 1 squared minus u squared is sine inverse of u over 1 plus c. So we have 1/4 times sine inverse of u over 1 plus c. Remember, u equals 4x, so we'll replace u with 4x, and 4x over 1 is just 4x. So we have 1/4 times sine inverse of 4x plus c. And this is our final answer.